Let's find the intervals of increasing, decreasing for the function h at x is equal to x times the square root of 2 minus x squared. We can see that first we got to find the critical value, so we follow step 1, which means that we take the derivative, set it equal to 0, and solve. So when we take the derivative of this, we can see that it's a product of two functions, x and the square root of 2 minus x squared. So that requires us to use product rule. So the first function is f, which the first function f is x, and the second function is the square root of 2 minus x squared. So I'm going to change that to 2 minus x squared to the 1 half. F prime then is going to be equal to 1, and g prime, we're going to need to use chain rule here. So that's an exponent. That 1 half is an exponent. We're going to throw that 1 half out front, take the root of the outside function, keep the inside the same, and then subtract 1 off the exponent, and then multiply by the root of the inside. So the derivative of 2 minus x squared is, of course, negative 2x. And I like to simplify the stuff over here instead of simplifying it in the derivative. So I'm going to clean this up to get negative x times 2 minus x squared to the negative 1 half. Okay, now h prime then is going to be f prime g, so 1 times g, which is 2 minus x squared to the 1 half, plus g prime f, so minus x times 2 minus x squared to the negative 1 half, so that's g prime. And when I multiply it by f, I'm just going to make this squared out front. Okay. Now I can factor this, right? But both these terms are the two terms, so this first term and then this second term. They're already cleaned up as nicely as you can. So now I'll move on to factoring. I see that they both have a function of 2 minus x squared in common. And then to the lowest exponent is negative 1 half. So that's what I'm going to common factor out. If I common factor 2 minus x squared to the 1 half by 2 minus x squared to the negative 1 half, I factor by division, right? So really I subtract the exponents. So 1 half minus negative 1 half is positive 1. So I get 2 minus x squared to the 1. And then out of this last term, I'm pulling this 2 minus x squared to the negative 1 half out, so I'm left with a minus x squared. Now we can clean up on the inside, and we get 2 minus x squared to the negative 1 half still. And then on the inside here, you can see you get 2 minus 2x squared. I can continue to common factor, so I get I can common factor a negative 2, and I'll be left out of here with an x squared minus 1. And now I will move the 2 minus x squared to the bottom, so that's going to become the square root of 2 minus x squared. So there's my first derivative, which now I set that equal to 0 and solve. When I set that equal to 0 and solve, of course, the denominator isn't going to come into play here. So I'm going to get, I'm really just solving x squared minus 1. And x squared minus 1, if x squared is equal to 1, and x is equal to plus or minus 1 are my critical values. We have our critical values. We can plot that in the domain on a number line to get our intervals. That's step 2. So we did the domain in a previous tutorial, and we showed that it's actually bounded between two endpoints, and those endpoints were negative root 2 and positive root 2. And now we can plot our critical values of negative 1 and 1 here. So, and that's because there's a root here that we get this bound. This number, negative root 2, is approximately equal to negative 1.4. And this number, root 2, then is 1.4 approximately. That'll help us to choose test values. So we choose test values between the intervals and from within the intervals. And these intervals, we have 3 of them here. So let's choose negative 1.2 for this one. There's really no nice answer for there. 0 would be a good test value there, and f prime at 1.2. Let's go from the second interval. Okay, let's work this out. If we put negative 1.2 into the first derivative, we get negative 2 times negative 1.2 squared minus 1 all over square root of 2 minus x, oops, sorry, not x, we're subbing it in, 2 minus 1.2 squared. Which, remember, we care about whether this is positive or negative, so the negative 2 is going to keep a negative out front. This negative 1.2 squared, that's going to make 1.44, and then we subtract 1 from that, so we're going to get a positive on the inside of the bracket there. And then on the bottom, this 2 minus 1.2 squared, we're going to get a positive. So we get a negative up top divided by a positive, so we get a negative answer. So therefore, it's decreasing on this interval. For 0, when you plug in 0, you can see that you'll get a negative from within the bracket, times a negative makes it a positive, divided by a positive on the bottom makes a positive increasing interval. And then when we sub in 1.2, it's very, very similar to subbing in negative 1.2, so we're going to get a negative interval here. So what we know then is, therefore, we are decreasing from negative root 2 to negative 1, union with negative 1 to root 2, and then we are increasing from, from negative 1 to 1. And one could argue that instead of, because we have endpoints, we can say that this is actually increasing at negative root 2 and here. But that's not really important. You could keep it as a circle bracket or a square bracket there.
What you waiting for? Move, keep them going till your life is overflowing, yeah. I do a dance of victory, 'cause now I'm living good, no I'm not living like I used to be. Now talk about things, talk about my mind. Now I'm free from the words that I left behind. I gotta